Hi everyone. In this lesson we are looking at Chapter 5, Section 3, Medians and Altitudes of a Triangle. Our objectives are to use the properties of medians of a triangle and use the properties of altitudes of a triangle. Standards are G-Code 10. We start with definitions. Our first vocabulary word is median of a triangle. A median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. This is important to know as it's different from the altitude of a triangle, which we will see in a little bit. So a median goes from the midpoint of a side all the way up to the vertex. So across from the midpoint up to the vertex, and that is the median of a triangle. The centroid of a triangle is the point of concurrency of the medians of the triangle. What that means is it's where all of the medians meet in the middle. So you'll notice that this median over here of this side, this median over here, and this median over here meet in the middle, and this is considered our centroid of the triangle. Altitude of a triangle. Altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. So notice that the median and the altitude are different. The median goes from the center of the side all the way up to the vertex, and the altitude, it doesn't matter where it is as long as it can create a 90-degree angle. So it creates a perpendicular distance from the side all the way up to the opposite vertex. So that's what you want to understand. The difference between the altitude is it creates a perpendicular distance, whereas the median is from the center all the way to the vertex. And then orthocenter of a triangle. The orthocenter of a triangle is the point of concurrency of the lines containing the altitudes of the triangle. So remember, point of concurrency is where all of these medians meet, and so depending on the type of angle, depending on the type of triangle, your point of concurrency will be different. So in a acute triangle, the orthocenter is in the middle. In a right triangle, the orthocenter is right where the right triangle is at that vertex, and in an obtuse triangle, the orthocenter is outside the triangle. Theorem 5.7, concurrency of the medians of a triangle. The medians of a triangle intersect at a point that is 2/3 from the distance from each vertex to the midpoint of the opposite side. So if P is the centroid of triangle ABC, so P is the center of this triangle ABC, then AP, this line here, is 2/3 from the entire distance of the line, which is AD. So AP is 2/3 of AD. And we can say the same thing about line BP. Line BP is 2/3 of the entire length of BF, and CP is 2/3 of the entire length of CE. Concurrency of altitudes of a triangle. The line containing the altitude of a triangle are congruent. So if line segment AE and line segment BF and line segment CD are altitudes of triangle ABC, then line AE and line BF and line CD intersect at some point H. Let's take a look at our first example using the centroid of a triangle. So we are given that R is the centroid of triangle STU and that SR is 16. We need to find the measure of SV. Since SR goes from the vertex to the centroid, I know that this length SR is 2/3 of the length SV. So from here, I can plug in what I know. I know that SR is 2/3 of SV. I know that SR is 16. And that's 2/3 of SV. So to solve for SV, isolate SV by multiplying both sides by the reciprocal of 2/3, which is 3/2. And when you multiply that and simplify, you get that SV is 24. So this entire length, S to V, is 24 units. So we found SV. Our next one is to find RV, which is this length over here. Well, there's two ways you can do it. You could know that since SR is 2/3, is from the center to the centroid, then RV is 1/3 of this entire length of SV. Or we could use the segment addition postulate, knowing that SR plus RV gives us SV. We know what SR is, that's given, that's 16. We also just found what SV is, which is 24. Subtract 16 on both sides and we get that RV is 8. So SV is 16 and RV is 8. Example number 2, finding the centroid of a triangle. In this question, we are to find the coordinates of the centroid of C of triangle DEF. So we need to find what is the center of this triangle DEF and label that point C. So you know that the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So we know that the centroid is about 2/3 away from this vertex, and this is at the midpoint. Well, so our first step over here is to find our midpoint or our median. And in order to do this, remember the median formula, and I'll write this over here, is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So let's plug that in. We got our x1 as 1 and x2 as 9. Divide that by 2, so that's 1 plus 9 is 10. 10 divided by 2 is 5. And then find our y coordinates of our midpoint, so that's 1 plus 1 divided by 2, which is 1. So our midpoint over here, which is J, is located at x equals 5 and y equals 1, which you can see in the picture. Our next step over here is to find the distance from the vertex E to the midpoint J. So remember your distance formula is square root of x2 minus x1 plus, and that's square, plus y2 minus y1 square. And if we go back to our picture, we'll note that our x1, so we're finding the distance from E to J, so our x1 is 5 minus 5 square plus 7 minus 1 square. 5 minus 5 is 0, and we've got 7 minus 1, which is 6 square, which is the square root of 36, which gives me 6. So the distance between point E to J is 6 units, and they just did 7 minus 1. I did it the long way for more practice. And then it says determine the coordinates of centroid C, which is 1/3 of 6, because if you looked at the triangle over here, now I'm going to quickly draw it. We're going from the midpoint of the line segment DF. So we were going from the midpoint, which is J, all the way to the center, and since it's going from the midpoint to the center, this distance over here is 1/3. If we were going from the vertex to the center, that would be 2/3. So we're looking for 1/3 of this entire distance, 6, or 1/3 of 6 is 2 units up from point J, this is point J, along the median EJ. So the coordinates of centroid C are 5 and 1 plus 2, or 5 and 3. So the reason why it is 1 plus 2 is because the y value over here is 1, and we went up 2 units over here, so it's 1 plus 2, and that gives us our centroid, which is 5 and 3, because we already know our x value is 5. Alright, it's your turn. I want you to do checkpoint problem number 1. It says T is the centroid of triangle QRS and TU is 7 units. Find QU and QT. That's it for me for now. See you later.